Today, we're talking about how our modern world of travel was invented. But here's the twist. This isn't going to be your typical story about lone geniuses having eureka moments. Nope. This is a story about an unbreakable chain, a series of discoveries that maybe, just maybe, were destined to happen.
Think about it. We give all the credit to guys like Carl Benz or the Wright brothers for the car and the airplane. But what if? What if their inventions weren't so much unique acts of genius, but were just the next logical step? Something that was pretty much guaranteed to happen once a certain scientific key was turned. That's the huge question we're tackling.
All right, so let's get into it. We are going to trace this incredible, unbreakable chain of invention. You're going to see how figuring out one basic rule of science just unlocked the door to the next big thing, and then the next, in a perfectly logical line that literally built the world we live in. So where does this story begin? Well, it all starts with the first, and honestly, the most important link in the whole chain. The engine. But not just any engine. We're talking about the one that completely changed the game by putting power exactly where you needed it.
Okay, so before all this, we had steam power. And yeah, it was revolutionary, but it was what you'd call external combustion. The fire was on the outside, boiling water to make steam. This meant they were huge, heavy, and just not very efficient. The absolute game changer was figuring out how to bring the fire inside. That's internal combustion for you. A tiny, contained explosion pushing a piston directly. So much lighter, so much more powerful.
And what's the secret sauce here? It's something super simple. A basic law of physics you probably learned in high school. When you heat up a gas, it expands, like violently. The entire internal combustion engine is just a clever machine built to capture the power of that one, simple, totally predictable property of nature.
And this is how it works, this brilliant four-step dance perfected by Nicholas Otto. First, you've got intake. A mix of fuel and air gets sucked into a cylinder. Then, compression. A piston shoots up and squeezes that mix tight, making it super explosive. Step 3, the best part. Power. A spark ignites it. Bam! The explosion slams the piston down. That's the moment that makes everything go. And last, exhaust. The piston comes back up, pushing all the used-up gases out. It's this cycle of suck, squeeze, bang, blow, happening thousands of times every minute.
The result of this new way of thinking was just staggering. The power-to-weight ratio went through the roof. Think about this. In just 20 years, the amount of engine you needed for 1 horsepower dropped from 440 pounds down to just 9. That's a 98% reduction. This wasn't just a small improvement, it was a revolution. Suddenly, you had an engine that was light enough and powerful enough to stick on pretty much anything.
And you know, the first obvious place to put this goo engine was on a carriage. Which brings us to the next link in our chain, the birth of the automobile.
People have been dreaming about a horseless carriage for ages, but the problem was always the steam engine. It was just way too heavy and clunky. It was like trying to power a go-kart with a locomotive engine. It just wasn't going to happen. This new, lightweight internal combustion engine wasn't just a better option, it was the only option. It was the missing piece of the puzzle everyone had been waiting for.
And as soon as that puzzle piece clicked into place, man, things took off. Look how fast this happened. In 1885, Carl Benz slaps his engine on a 3-wheeler. Just a few years later, somebody figures out a better steering system for 4 wheels. By 1895, you could actually go out and buy a car. And then boom, 1908, Henry Ford starts pumping out the Model T for everybody. The whole thing just exploded once the main problem, the engine, was cracked.
And here's the really crucial part. All the other bits and pieces of a car, people basically already understood them. We knew how gears worked, how to make things steer, how to brake. These technologies were already around, used in things like carriages and other machines. They were all just sitting there, waiting to be bolted onto this amazing new power source.
But why would you stop at just roads, right? The exact same breakthrough that was putting us on highways was about to lift us clear into the sky. So the next logical link in the chain had to be flight.
For hundreds of years, the dream of flying was all about strapping on some wings and flapping like a bird. These things were called ornithopters, and, spoiler alert, they all ended in failure. It wasn't for lack of trying, though. The dream was there, the passion was there, but our muscles just can't produce enough power. The problem was never imagination. It was pure physics.
So the real secret to flying had nothing to do with flapping. It was another fundamental law of physics, this one figured out by Daniel Bernoulli. His theorem is pretty simple. The faster a fluid, like air, is moving, the lower its pressure becomes.
That simple little relationship between speed and pressure is what allows a giant 200-ton jet to get off the ground.
And here's how it's put to use. See how an airplane wing is curved on top? That little shape forces the air to travel a longer path over the top than it does on the flat bottom. And to cover more distance in the same amount of time, that air on top has to speed up. And what did we just learn? Faster air means lower pressure. So now you've got high pressure under the wing and low pressure above it. The wing literally gets pushed upwards. And that, my friends, is lift.
Now, pioneers like Otto Lilienthal and, of course, the Wright brothers had totally mastered this principle with gliders. They knew how to create lift, they knew how to control a craft in the air. For all intents and purposes, they had solved the theory of flight. But to stay up there, you need a constant stream of air flowing over the wings. Gliders have to rely on wind and gravity. To make their own wind, they needed the exact same thing the automobile needed, a small, lightweight, powerful engine. So once the Wrights managed to build their own custom internal combustion engine and strap it to their glider in 1903, the world changed all over again. And just look at this growth. In only 20 years, air travel went from this crazy experiment to a real industry. The number of passengers multiplied by 45 times. It's the exact same pattern. Once that essential link in the chain was forged, progress just went vertical.
But the chain didn't end there. Propellers were great, but to go even faster, even higher, we needed to tap into a different law of physics. This time, it was Newton's third law. You know the one. For every action, there's an equal and opposite reaction. The idea that if you throw a whole lot of something backwards really, really fast, you'll get pushed forwards. That simple, beautiful law is the key to the entire jet age.
Okay, let's just step back for a second and look at the whole incredible picture. We've seen exactly how one discovery led directly to the next, forging this unbreakable chain.
It all kicks off with the basic property of nature. You heat a gas, it expands. That understanding lets us build the internal combustion engine. That engine's amazing power-to-weight ratio makes the automobile possible. That very same engine then gives us the missing piece for the aeroplane. And then a different law of physics, Newton's third, launches us into the jet age. You see, every single step depended on the one that came right before it. You couldn't just invent the car out of thin air, you needed the engine first. And you couldn't have powered flight without first figuring out gliding and having that very same engine.
So the real takeaway here is this. These inventions that completely changed our world weren't just random lightning strikes of brilliance. They were the logical, almost inevitable next steps in a process that was dictated by the laws of science itself. As soon as we understood a principle and built the tool for it, the next invention was basically just sitting there, waiting for someone to put the pieces together.
And that leaves us with a really fascinating question to think about. If you look around at the science of today, at AI, at gene editing, quantum computing, what are the fundamental links that we're forging right at this very moment? And what incredible world-changing inventions are just waiting on the other side as the next inevitable link in this unbreakable chain?